Hilchos Kiddush Hachodesh Perek Shisha Asar. The laws of sanctifying the new month, chapter 16. Today the Rambam is going to introduce us to an entirely new concept as it relates to the moon, and so we need a quick introduction. The earth is a sphere. It's a ball. When you have a ball, there's no real top or bottom, beginning or end. But for the purposes of simplicity, we define the top of Earth as the North Pole, and the bottom of Earth as the South Pole. And then in the middle, there's a line that wraps around the belly of the ball that's called the equator. And this way, I can tell you where anything is on the world. It's on the top half of the world, it's on the bottom half, it's on the northern hemisphere, the southern hemisphere, it's above the equator, below the equator. But that's a very general type of identification process. There's another, more precise way of telling you where something is on the ball of Earth, and that's called longitude and latitude. Mathematically, we draw lines across the world, going from the North Pole to the South Pole, a bunch of lines, and that tells you what is the eastern or western position of anything on Earth. Because you choose a line of longitude and you say, this place is eastward of this line, or westward of that line. Then you also have what's called latitude. Latitude are mathematical lines that we draw around the world, above the equator and below the equator. And this way, the lines, they go east to west, but they can tell us the position of something north or south. You say something is north of this line of latitude, or south of this line of latitude. And besides for telling you the location of something, they can also help you define distance between two objects, between two locations. So for example, in the United States, right? If you wanted to know how far is California from New York, that's an east-west distance. California's on the west coast, New York is on the east coast, so you would use the lines of longitude. You would say New York is 3 lines of longitude away from California. But if you wanted to know the distance between Texas and North Dakota, that's a north-south distance, so you use the lines of latitude. And you say, North Dakota is X amount of latitude lines away from Texas. Now, a few times in these chapters, we learned about what's called the Galgal Hayomi. The fact that all of reality is as if it's within a ball that's turning from east to west. The Galgal Hayomi, this outermost sphere, has the same orientation as Earth. That means its top is also the most north, its bottom is also the most south, and its equator, in other words, the line that runs directly in the middle of it, is from due east to due west. It's exactly like the Earth. Imagine as if the Earth ball would just zoom out. And so, since time immemorial, astronomers have been drawing what's called celestial lines of longitude and latitude. Just like on the map of the Earth, you make lines to define the distance between locations on Earth, you also extend those lines outward to be able to define the distance between objects in the heavens. And you say, this is here, and this is to the west of it. There are 3 lines of latitude away. Or this is to the north, this is to the south. There are 3 lines of latitude away. Longitude going this way, latitude going that way. And so you're able to define the position of stars and planets based on these celestial means heavenly, lines of longitude and latitude. In the Rambam, longitude is called orech. Whenever you see the word orech, length, in these coming chapters, it refers to longitude. Whenever you see the word rochav, which means width, it refers to latitude, to the northwest distance. Now, where are we in our journey of discovering whether the moon can be sighted? We've made corrections in the last couple of chapters to the position of the sun and to the position of the moon. We understand that when we say that the sun is somewhere, that only means it's somewhere on its own orbit. But relative to the observer on Earth, it's going to be in a little bit of a different place. That's the correction. Same thing with the moon. Because the moon is traveling simultaneously on the big orbit and also on the small cycle, so we have to correct the position of the moon to know where it's going to be seen from Earth. However, all of those corrections that we've been learning until now are longitudinal corrections. That means after the correction, the sun is more east or more west, or the moon is more east or more west than where it was originally. If we say it's at 90 degrees and now, based on the correction, it's at 80 degrees, that means it's moved a little bit more to the west. Or if it's from 90 to 100, it's moved a little bit more to the east. But it's all on that plane of east to west. With the moon, though, that Rambam's going to introduce today, we also have to make a latitudinal correction. We also have to account for the fact that the moon may be seen more north or more south than where it originally is. Why is that? Because until now, we've been using the Galgal HaMazalot, that belt of stars, as the backdrop to define where the sun and the moon are moving against it. But the truth is that only the sun runs directly under the path of the stars. The moon's orbit is inclined 5 degrees further than that belt of stars. You can try to see it over here. I don't know if it's so clear. The circle in the middle is the moon's orbit. And you can see it's bent a little more north and a little more south than the Galgal HaMazalot. Maybe this picture will be a little bit more helpful. Just kind of brings out the point that if you're on Earth and the sun and the moon are in molad position, they're aligned, but the truth is they're only aligned as far as east-west goes. As far as north-south goes, the moon is a little bit more north than the sun. Or it could be the opposite in this case. It could be lower, it could be southerly. And by the way, in these pictures it's higher and lower, but for us, if you're standing on the street, north and south actually means more right and more left. The only reason it shows you here higher and lower is because we're looking at Earth from a bird's eye view where the North Pole is on top, South Pole is on bottom. But for us in our personal experience, it's actually, when we say north and south, we mean that the moon will be sighted either to the right or to the left more than you might basically think it based on the last couple of chapters. We have to take into account that the moon is inclined 5 degrees further than the Galgal HaMazalot. Galgal HaMazalot is inclined 23.5 degrees off the equator. The moon's orbit is another 5 degrees for a maximum of 28.5 degrees. That means, as the Rambam will explain momentarily, that there's only 2 points where the orbit of the moon and the orbit of the Mazalot meet. Like when you have any 2 circles, you put one ring inside the other. If they're inclined to each other, they're only going to meet at 2 points. Those 2 points in the Rambam are called the Rosh and the Zanav. The head and the tail. See there? The Rosh and the Zanav. Those are the 2 points where the moon's orbit is in line with the Galgal HaMazalot. Now this explains, by the way, a question that other people asked a couple of days ago. How come there's no solar eclipse every month? Right? If the molad means that the moon and the sun came into alignment from the perspective of the viewer on Earth, so every month the moon should be covering the sun. But the answer is because when the molad happens, it's only longitudinally combining.
The sun's covering the moon, no?
No, from somebody on Earth, it would be the moon covering the sun.
Okay.
But the reason that there's no eclipse every month is because typically the sun and the moon are only aligned in longitude, they're not aligned in latitude. Only when they're both aligned in longitude and latitude, that's when you have an eclipse.
But the moon is much smaller than the sun, so will not
Doesn't matter.
covered.
No,
it's just the perspective of your angle of looking.
Yes, yes. I mean, if you've ever seen a solar eclipse, that's what happens.
But the solar eclipse is actually...
Solar eclipse is when it's aligned both in longitude and in
You don't have
latitude.
an eclipse every single month because they are moving?
No, it's because besides for the meeting east-west, there also has to be a meeting of north-south.
So we see the north-south, we don't see the east-west.
Right. The eclipse would only happen when they meet on both.
Right. Since it's high, is that because it's higher?
Yes.
Is it?
Yes. Or in our case, it's more right-left, let's just call it. This way and that way. A monthly eclipse, exactly. It'd be a monthly eclipse.
Very nice.
Now, follow this, please. Okay, it's a little bit complicated.
Oh, now it gets complicated? That's funny.
This north-south correction could very much affect the sighting. Why? The more north something is, the later it will set on the horizon of somebody who's sitting in Jerusalem. The more south it is, the earlier it will set on his horizon. I'm trying to demonstrate it here in this picture, okay? that yellow line over here, this yellow line, is Yerushalayim. Okay? So somebody standing in Yerushalayim, at any point, we always say you can see half of the heavens. Your horizon is half of the heavens. So this blue, transparent dome represents the person's horizon from Yerushalayim. Once something hits this point, it has set below your horizon, you can no longer see it. But you can see that from this point on Earth, the more north something is from the equator, the longer journey it has to get to the horizon. The more south something is, the shorter journey it has to the horizon. Now, if you'd be standing over here on the equator and your dome would run literally this way, then north-south wouldn't make a difference. But because you're in Yerushalayim, this is going to keep on coming up again and again, today and tomorrow. Because you're in Yerushalayim, the more north, the later the set is. The more south, the earlier the set is. So we have to know where is the moon. The more northerly it is, the more time we're going to have to see it, because it's going to take longer to set. The more southerly it is, the less time we're going to have to see it, and the less time we're going to be able to sight the new moon. The little way to think about this is, I don't know if you've ever watched like sunrise, sunset, from, like if you're on Ventura Boulevard, it never actually rises in the east and sets in the west. The sun doesn't go like this. Because it's inclined, it goes like this. There's an angle. So therefore, the more north it is, the more time it takes to get there. The more south it is, the quicker it gets there. Okay? That's the basic introduction that we need for today's parak. Let's do the Rambam inside, and then we'll see how it gets a little more. The plot thickens a little bit more, but we'll start with this. Halacha Aleph. Ha'igula sheseveves ba hayareach tamid. The orbit around which the moon constantly journeys, hi noita me'al ha'igula sheseveves ba hashemesh tamid, is inclined off of the orbit, the belt, which the sun follows. Chetzia noita letzafim, v'chetzia noita ledarim. Half of it is inclined more north, half of it is inclined more south. Again, that's the pictures over here. You can see there's a north and south inclination. There are 2 points on the orbit, one opposite the other, on which both circles meet. Therefore, if the moon is on one of those points, so it is essentially orbiting along the same latitude as the sun is orbiting. It's not inclined more north or more south. However, the moment the moon leaves these 2 points of departure, it's automatically either inclined to the north or to the south of the moon. The point from which the moon begins its northerly inclination is called the head. And the point from which the moon begins to go south is called the tail. And now the Rambam introduces yet another complexity to the equation. The Rosh and the Zanav, these 2 points of meeting, are not stationary. See, if they would be stationary, it would be super easy. The Rosh is always at 0 degrees, the Zanav is always at 180 degrees. When the moon is between 0 and 180, we know it's north. When the moon is between 180 and 360, we know it's south. The problem is that the Rosh and the Zanav themselves move around, and I could not get this video onto the screen, so I'm going to show it over here. I want to just see if you can see it. Great. Just to demonstrate this concept. This is a video I made the other year, so it has me also talking, but you can see the imagery. Watch. See that? Those points themselves are moving.
I mean, obviously, because it moves every month. The moon's orbit.
But the whole circle is moving. It's turning in place. In other words, the point of inclination is always different.
On navigation charts, I think they're called nodes.
Yes.
Yeah.
Yes.
Yeah,
They are called the nodes.
yeah, where there's I think they have a 20-year cycle.
I haven't checked into it.
20-year cycle?
Yeah, the points where
The point is,
orbits of
yeah.
the moon and the elliptical plane meet.
Those 2 points are also moving.
The Rosh and Zanav.
Yes. The Rosh and Zanav.
So the whole circle is moving besides for the moon
Yes.
moving on it.
Besides for the moon moving on the orbit, the whole orbit is moving. So that now, in order to know whether the moon is north or south, you have to first determine where are the 2 points, and then how far did the moon get from those 2 points, and then you could know where exactly it is, north or south. That's what the Rambam says right now. Umahalach shave yesh lezeh harosh. This head, and the truth is automatically also the zanav, of course, but we're just going to focus on the rosh, has a steady rate of progress. She'ein be'loi tosefes v'loi geroi, and it never gets faster or slower. It's constantly moving. V'hu hoylech b'mazolos achayranis, and it's going backwards relative to the Galgal HaMazalot. In other words, it's going from east to west. Mitola lidogim, umidogim lidli, from Aries to Pisces, from Pisces to Aquarius, v'cheinu seiviv tamim, and so it's constantly turning. It goes backwards the opposite way of the sun and the moon.
So this is going east to west.
Yes,
And the Mazolos is going west to east.
exactly. Beis, as the Rambam does, he gives us what is that rate of progress so we can be able to calculate for future calculations. The movement of this rosh, this departure point, on average, every day is shleisha chalakim v'achas esrei shniyos. It's very slow. 3 minutes and 11 seconds of 1 degree. So there's 60 minutes in a degree. So it's like, what is that? 3 out of 60 is 1/20th. 1/20th of a degree. Nimtza mahalache ba'asara yamim. So in 10 days, it achieves a progress of Hachodesh leishim chalakim v'sheva v'arbaim shniyos. 31 minutes and 47 seconds, just about half a degree. V'nimtza mahalache b'mea yamim chamish mailos shivasar chalakim v'shalosh v'arbaim shniyos. In 100 days, it goes simanam hey yud zayin mem gimel 5 degrees 17 minutes 43 seconds. V'nimtza mahalache be'elef yamim shtayim v'chamishim mailos v'shiva v'chamishim chalakim v'eser shniyos simanam nun beis nun zayin yud. In 1,000 days, about 3 years, it only goes 52 degrees, 57 seconds and 57 minutes, 10 seconds. In 10,000 days, the remainder of it is, in other words, it makes a full cycle plus a little bit. 169 degrees, 31 minutes, and 40 seconds.
So is that why it's happening every 29 years in Israel?
No, the time was the sun.
Nothing to do with it.
Yeah.
So what happens after 30 years? After SRS 11, right?
It's that's just how much the Reish goes around. He's just giving you the rate of progress of the Reish so you can know where to calculate it at any time. The rate of progress for 29 days, which is the important one for our calculations every month. How far does it move? 1 degree, 32 minutes, 9 seconds. In a regular year, a regular lunar year, how much does it move? 18 degrees, 44 minutes, and 42 seconds. Now the Rambam has to give you the starting point. At the beginning of Thursday, the starting point, where was the Rosh? Where was this point of departure? 180 degrees along the Galgal HaMazalot, 57 minutes, 28 seconds. Now that you have the rate of progress and you have the starting point, so if you want to know where is the Rosh at any given time, you can figure out the rate of progress, the position for that time, the same way you figure out where the average sun's position or the average moon's position is. However, because it moves backwards, you have to convert the number. The tigra ha'emtza mishleish meis v'shishim mailos, and you subtract that number from 360. V'hanishar hu mekayim harosh ba'osei ha'es. The remainder of it is the placement of the rosh at that time. U'kenegdei la'olam yeh mekayim hazanav, and exactly 180 degrees opposite it will be the place of the tail, the other point of departure. In other words, because the rosh travels the opposite way, so if the calculations tell you that the rosh is at 10 degrees, it means 10 degrees on its backwards journey. So you take 360, you subtract it with 10, and you're left with 350. On the Galgal HaMazalot, it's at 350. That's actually where it is. It's 10 degrees away from the beginning, the other way. It's 350 on the regular way. Ketzat, the Rambam visualizes this. How does this look like? If you wanted to figure out where is the placement of the Rosh at the beginning of Friday, second day of the month of Iyar, this year the starting point, it's 1 month after the starting point. The amount of complete days that has passed from the starting point till this night that we want to know where the Rosh is 29 days. Figure out the position of the Rosh for this time on the way that you know. In other words, I've given you the progress, which is shetoisif mahalacha letisha ve'esrim alo ikar. Add the progress for 29 days to the starting point. Yetzi lecha emtza harosh. So the placement of the Rosh will come out to be, again, it began at 180. So now it's where? Meo ishtayim u'shmeinim miles v'tisha ve'esrim chalakim v'sheva u'shleishim shniyos simanam kuf pebeis chavtes lamed zayin. It's at 182 degrees. 29 minutes, 37 seconds, but 182 degrees on its way of orbiting, the opposite way. So how do we figure out where that is for us? Tigra emtza zeh mishleish meis v'shishim. Subtract this number from 360. Yishar lecha mea v'sheva v'shivim miles v'shleishim chalakim v'shalish v'esrim shniyos simanon kuf ayin zayin lamed chaf gimel. It's at 177 degrees, 30 minutes, 23 seconds. The mirror image, the inverted placement based on the regular calculation from 0 to 360 from west to east. That's the placement of the Rosh. No need to look at the seconds, they're not important for these calculations. So for our purposes, where is the Rosh on this day of the starting point, which we're looking for? In the constellation of Virgo at 27 degrees and 30, about halfway through the 28th degree. 180 degrees exactly is the placement of the Zanav, the other point of departure. The Mazel Dagim, B'Sheva ve'esrim Milos, Shleshim Chalakim, in the Mazel of Pisces, 27 degrees, also and a half, 30 minutes, because it's one opposite the other exactly. Halacha Vav, the Rambam repeats the point, doubles down. Lo'olam yiyeh bein harosh u'bein hazanav, chatzi hagalgal b'shava. Always, between the Rosh and the Zanav, there's an exactly half of the belt of the Mazalot. Lefichach, therefore, kol Mazel shetimtza by Mekoim harosh, the constellation in which the Rosh is found, Yiyah hazanav b'mazel shvi'i mimenu b'k'may minyan hamayles v'achalakim b'shava. The Zanav will be exactly 7 constellations away. In other words, including that one. It's really 6 constellations away, but it's 7 including the one that it's in. The exact same number of degrees and minutes. Im Yiyah harosh be'eser miles b'mazel plaini, Yiyah hazanav be'eser miles b'mazel shvi'i mimenu. Once the Rosh is at 10 degrees of one constellation, the Zanav will be 10 degrees, exactly 7 constellations away. Now we can begin to make the adjustment for the Roichav. The Rambam, now that you know how this works, so the Rambam will tell you, figure out all the 3 relevant points. Once you know the placement of the Rosh and the placement of the Zanav, and you also know the true position of the moon, based on the last 2 chapters that you've calculated where the moon exactly is, compare the 3. If the moon is together with the Rosh, or together with the Zanav, at the same degree and the same minute, you will then know that the moon is exactly aligned latitudinally. It's not north or south inclined relative to the sun. But if you observe that the placement, the degree of the moon is ahead of the Rosh, walking towards the Zanav, as in this picture here, it's moved away from the Rosh, it's journeying here towards the Zanav, you will then know that the inclination of the moon is a northerly equation, as in this picture. Right? When the moon is journeying from the Rosh to the Zanav, it'll always be seen more north than the sun. But if the opposite is true, if the moon is on the other half of the circle, it's ahead of the Zanav journeying towards the Rosh, you will then know that the moon is inclined southerly relative to the sun. Halacha Ches, this inclination which the moon has to the north or to the south, is what we're going to call in these chapters the width of the moon. Width of the moon means the latitudinal difference between the sun and the moon. If it's northerly inclined, we call it a northerly reichav. If it's southerly inclined, we call it a southerly reichav. If the moon was at one of the 2 points, the Rosh or the Zanav, of course it has no inclination, it has no width, because there is no latitudinal difference between the sun and the moon. Now, how much is the inclination of the moon? So I already told you in the introduction, and the Rambam says it here. The maximum inclination of the moon both to the north and to the south, can only be 5 degrees. This is the way it goes. It begins at the point of departure, the rosh, the head. It distances itself little by little. And the distance keeps on adding till it reaches a maximum inclination of 5 degrees. Then it gets closer and closer, journeying downwards towards the Zanov. To the point that it has no more inclination once it reaches the tail. Then it will keep on going and getting further, a little bit more, little by little, on the other side. And the distance keeps increasing till it reaches an inclination south now of 5 degrees. And then it continues to come back to the point that there is no inclination anymore. Now, how do you adjust for this reichav? So again, we have to trust the Rambam. He gives us the table. If you wish to know the inclination of the moon, the latitudinal inclination of the moon, how much is it at any time? If it's north or south. You simply have to figure out where is the rosh and where is the position, the true position of the moon. Subtract the number of degrees where the rosh is from the number of degrees where the moon is. And what remains is called the path of the latitudinal inclination. You can see it a little bit over here. You figure out where the rosh is. You figure out where the moon is. The distance between the rosh and the moon is called the maslul hareichav, the path of the inclination. And based on that distance, the Rambam will give us a table to tell us how much the inclination is. And here goes.
How much the inclination of
the moon, north or south, is.
I see, okay.
If the number you come up with is between 0 and 180, in other words, the moon is from the rosh, making its way to the Zanov, you will know the inclination is northerly. If the number you reached was more than 180, in other words, it's journeyed from here more than 180 degrees, you will know that the inclination latitudinally is southerly. If you discover that the moon has distanced itself from the rosh exactly 180 degrees or exactly 360, i.e. 0 degrees, there is no inclination for the moon at this point, and that's it. You don't have to do any further calculations. But once you have established the distance of the rosh from the moon, then go check out my table that I'm about to give you to determine the angle caused by this path, caused by this course, how much it is. It's the amount of its inclination to the north or to the south. And what you're left with will be called the northerly latitudinal difference or the southerly latitudinal difference, as we've explained. Yud Aleph, okay, so give me the numbers. What's the adjustment? So the Rambam said, I've done the work for you. And he builds the table of adjustments around 90 degrees. Because again, 90 degrees is the maximum it can get. So once you know the adjustments from 1 to 90, you will automatically know the adjustments from 90 to 180. It's just inverted. And the same thing from 180 to 270. And from 270 to 360. Every 90 degrees, the table of adjustments is exactly the same. So the Rambam goes as follows. If the path, in other words, if the moon has distanced itself from the rosh 10 degrees, the angular adjustment is 52 minutes. For 20 degrees of progress, the adjustment is 1 degree and 43 minutes. For 30 degrees of progress, the adjustment is 2 degrees, 30 minutes, 2.5 degrees. For 40 degrees of progress, the adjustment is 3 degrees, 13 minutes. For 50 degrees of progress, the angular adjustment is 3 degrees and 50 minutes. Tia manase arba miles ve'esrim chalakim. For 60 degrees of progress, the adjustment is 4 degrees 20 minutes. V'miya maslul shivim tia manase arba miles u'shnayim b'arbaim chalakim. For 70 degrees of progress, the angular adjustment is 4 degrees 42 minutes. V'miya maslul shmeinim tia manase arba miles v'chamisha v'chamishim chalakim. We're getting very close. For 80 degrees of progress, the angular adjustment is 4 degrees 55 minutes. V'miya maslul tishim tia manase chamish miles. Once you hit 90 degrees of progress, that's the maximum northerly inclination of 5 degrees of adjustment. Of course, if there's individual units, if it's not 80 degrees, it's 81 degrees. You will take for yourself the number that befits them, based on the differential between the two angular adjustments for the 10 for each unit of 10. As you've done with adjusting the sun and adjusting the moon, you always, for singular units, you just find the difference. Ketzad, what does that look like, for example? If the course was not 50, not 60, it was 53 degrees. So you already know. For 50 degrees, it's 3 degrees and 50 minutes. For 60 degrees, it's 4 degrees and 20 minutes. The difference between the two is 30 minutes, which would mean 3 extra minutes per extra degree. So based on simple math, for this course, which is 53 degrees of progress, the adjustment would be 3 degrees and 59 minutes. And you can do the same for any given number. For a singular unit, you simply divide the difference between the two tens in 10 and add that amount. Or interpolate for the fancy word. Interpolation. Now that Rambam just gets lengthy about explaining what I told you before, how to apply this 90-degree table to all the other 90 degrees. Once you know the angular adjustment for the course of the moon till 90 degrees, as I've told you, you can now know the angular adjustment for any number on the course. If the course tells you that it's between 90 and 180 degrees, as in this picture, right over here, here's 90, the moon's at about 100. So between 90 and 180, simply tigra hamaslo mimeo shmainim v'hanishar teda by hamana. Subtract the number from 180, and the remaining number will dictate the angular adjustment. Because let's say it's at 100 degrees, right? So you subtract 180. You subtract 100 from 180, you're left with 80. Because at 100 degrees, the moon is actually 80 degrees away from this departure point. So the same way 80 degrees on this side would require X adjustment, so 80 degrees on this side would require X adjustment. It's the same thing, just invert it. On this half, from 180 to 270, take away 180, and the remainder you'll get the adjustment. Here you take away 180 because this departure point is like this one. So the same way if it got 20 degrees away over here, that would be the adjustment. If it gets 20 degrees away over here, same adjustment. If the course was anywhere between 270 and 360, subtract that number from 360 and you get the adjustment. Again, for example, if it's at 300, you subtract 300 from 360, leaves you with 60 because it's 60 degrees away from this departure point. So the same way 60 degrees over here would require X adjustment, 60 degrees over here would require the same adjustment. But the Rambam doesn't suffice. He gives us examples. Ketzat. Let's say the course was 150. Okay, on this, that would be like around over here. Right, because here's 180. So yeah, about 150 is about over here. Subtract 150 from 180. Nishar shleishim, you're left with 30. You already know the angular adjustment for 30 degrees is 2 degrees 30 minutes. So too, the angular adjustment for 150 will be 2 degrees 30 minutes. Another example. Let's say the path was 200 degrees. So in other words, it's about over here, right? The moon has traveled from here 200 degrees. Take away 180, Yishar Esrim. 20 is left, because that's what it is. It's gotten 20 degrees away from this departure point. You already know that the angular adjustment for 20 is 1 degree 43 minutes. So too, for 200, the angular adjustment will be 1 degree 43 minutes. Another example. This time it's in the last quarter. It's at 300. The example that I used before. Subtract it from 360. Nisha shishim, 60 is left. You already know that the angular adjustment for 60 degrees is 4 degrees 20 minutes. So the same will be for 300. It's an adjustment of 4 degrees 20 minutes. And just use the same method for all individual numbers. It just works. The system is self-working. Once you know from 0 to 90, you know all the other adjustments as well. And the Rambam concludes the chapter with visualizing that he just said for his starting point. Let's say we want to know how much is the latitudinal inclination of the moon and which direction it is, if it's north or south. On the night of Friday, second day of the month of Iyar from this year. So let's do it. We know where the moon's true position is. It's in the second constellation, 18 degrees in, 36 minutes. The Rosh is much further down. At that time, it's 27 degrees into the Mazal of Virgo, 27 and 30. Figure out the distance between the placement of the Rosh and the moon by subtracting one from the other. The course of the inclination, in other words, how far has the moon gotten from this departure point, will come out to be 231 degrees away and 6 minutes. And because we don't care about the minutes in this course, we're just going to take a look at the number 231. So the angular adjustment that we have to make for the moon at this time, based on the ways that we've told you, is shalish mailos ushleisha v'chamishim chalakim. It's at 3 degrees and 53 minutes inclined to the sun. Which way? This is the latitudinal adjustment for the moon, and it's to the south, because it's after 180. The course was more than 180. That means it reached the second departure point and continued journeying downwards. It's at 200 and whatever, 31. So that tells you that it's a southerly inclined reichav for the calculation that the Rambam is using.